This presentation on 3D printing, and we're actually going to look at the entry-level printing technology called fused deposition modeling, or FDM technology. So we're going to start that, and then the afternoon session we'll go into the remaining technologies all the way up to direct metal. So again, we're going to look at fused deposition modeling. I'm not sure how much you know about 3D printing, but this is the basic entry-level primer. This is introductory printing with 3D. Oh, sorry.
All this technology.
Yeah, all this technology. All right, so what is 3D printing? 3D printing basically adds a Z-axis or an up and down to what we're used to, the X and Y on paper. So the Z is the up and down axis. It's layer by layer printing, thus the term additive manufacturing. So we're adding layer upon layer to build our product or our part. There's about 7 different printing technologies out in the market today. Fused deposition modeling is the most basic entry-level technology. We'll look at a few of those this afternoon, but again, today we're going to look this morning at FDM. SLA technology, stereolithography, has been out since 1986. It was actually developed by 3D Systems, so it is the oldest, the best form of 3D printing out there. Again, we're going to look at FDM, fused deposition modeling, fusing layer upon layer. So how do we print with a 3D printer? What we do is we take a CAD file, we design something in CAD, we save it as an STL. STL is the standard file format for 3D printing currently. That file is then sent to your printer where it's basically sliced, and it prints layer upon layer of those slices, adding layer upon layer. So FDM, again, fused deposition modeling, how does it work? It's adding the Z-axis to the X and Y. How does it do it? It's basically a glorified hot glue gun. It takes a spool of plastic, pushes it through a heated print tap, drops it to the platform, and keeps outlining the part over and over again until it builds it. I do call it a glorified hot glue gun. That's the easiest way to think about it. That's exactly the technology. Nothing more than that. What is available from 3D Systems and what's out in the marketplace, I'll just give you a little bit of both. This is entry level. This is the small desktop version. This is the unit that you're selling off the shelf at Staples. It's about a $900 piece of machinery. It'll print you a 6x6x6 part with 2 different colors printing. The cartridges snap into the side. You can see them. They're proprietary. They're chipped like a wide format inkjet cartridge or your printer at home. And it reads how much is left on that spool. Again, you can print up to 23 colors. You can print in both ABS and PLA. PLA is just a green cornstarch-based plastic. So for those that have the necessity of printing green, that would be the PLA. It is also Wi-Fi. You can print it from your iPhone as well. Again, these are the smart cartridge system. You'll see some open source or open spools on a lot of the stuff that you're looking at on the internet. This is what sets the 3D line a little bit apart. It's actually enclosed, so your plastic's not spilling all over or spewing out. It's a controlled environment. Great for the school industry here. We see a lot of them in the K through 8 grades, all the way up to the high schoolers. As you can see, small businesses, again, off the shelf at Staples. Elementary, middle schools, of course, and this is a perfect environment for it, as you can see. Bigger guy, one step up, is called a Cube Pro. You're actually able to print about the size of a basketball in this unit. 1, 2, or 3 color marketplaces. You can see the MSRP, it's under $4,500. Gets you into 3D printing for a 3-color unit. Again,
What was the price before?
on the old version?
Older FDM printers, like from the competition?
Well, yeah, generally the FDM technology ranged anywhere from about $2,000 to $10,000 about 5 years ago. It's now down to $800 to $5,000. So the technology is coming down, price points are coming down, ease of use is making these units very popular. That's why we're starting to hear so much about it. And they're also starting to use different types of materials that we can all relate to. Things like plastic, PLA, chocolate, sugars, stuff that we're used to hearing about and we can now relate to as well. 3 different versions of this: single color, 2 color, all the way up to 3 color printing, about the size of a basketball as well. You can see this unit printing in here. The new Cube Pro, though, will give you the ability to print in multiple materials. So not only plastic, you'll also be able to print in nylon and polyester. So now you're getting the old school fused deposition modeling printers that used to cost you $25,000. You can now get into for about $4,500. This printer is going to print in 70 microns. So what you're looking at in here, Robert's printing in about 125 to 150. So when I talk about that, that's how thick that plastic is being melted out of that print tip. We're up to down to 70 microns. So now you're able to print microfine details actually on a FDM technology. So that's setting this printer apart actually. Again, 3 colors, you can see them layered. There's no color mixing, of course, because you're just melting plastic. Multiple materials, they come out with a different color every day. Fluorescence, sparkles, glow in the dark, very important colors. The new technology is going to allow you to do multiple materials. The nylon will actually be able to place you into printing prototypes for businesses. So this lower end printer is actually going to progress into that marketplace as well.
So if you have kids that want to create glow-in-the-dark parts for their Honda, they could do that. Put it on their car and drive at night.
Right, polyester materials as well, so we're all familiar with that. And now we've got this professional printability with these multiple materials available. So you're starting to see your low-end printers able to print multiple materials, thus getting you into multiple markets for under $5,000. All of the Cube and 3D systems comes with their own software. It gives you a copy of Cubify Invent, which allows you to create a product. It's almost like a free program on the internet called Tinkercad. If you're not familiar with that and you want to start learning how to 3D model, that's a great place to start. It's called Tinkercad. Cubify Invent as well does the same thing, same technology, drag and drop to create and invent, as well as your Cube software, which basically slices the file. You're able to print in color, so you can colorize your part as well at that point of creation. 3 different models again. We talk about number of print heads, that's up to 3 colors, multiple materials, peel away support. So this is kind of like, I'll go over that a little bit with you because as we progress this afternoon, you'll hear a lot about support systems. So what we talk about in 3D printing is when you start to print a project or a part, imagine printing a giraffe just for ease of imagination. When you get up to its chin, you cannot print its chin suspended in air. So it builds itself a support system or a little shelf to print that chin on. So that support system then needs removed. Every 3D printer in the marketplace uses some sort of support system. So post-processing or removing that support is what they talk about when they talk about the post-processing part of it. So that's always a good thing to ask somebody if you're starting to talk about 3D printing, what type of support system it uses, because that's going to tell you how much manual work goes into the process. Again, STL files is the standard file format. Our products also come, this is my sales pitch, free software, Wi-Fi capable, Mac and PC as well. Target market for this is the same as the Cube. It's still the FDM technology, but the multiple material capability should get us into slightly different marketplaces. It's a great entry-level point for anybody considering 3D printing. Another good thing to start looking at as well are 3D scanners. 3D scanners now come out from anywhere. The Sense scanner is $400 MSRP. So that gives us the ability to scan an object. The scan is then an STL file that we send directly to the printer. So we can actually teach the kids how to start the whole entire process for under $2,500 if we go single color. So we scan it, send it as an STL, and print it out. The Capture is a higher end scanner. It's still middle of the road. You can get scanners anywhere from $400 to $50,000. The Capture scanner comes in around $20-25, so it is middle of the road scanning. Still great for the X60 units that you see in here, as well as some of the higher end, but it's truly not top of the line. But the $400 scanner is a great way to get into that marketplace as well. All right, now that's basic FDM technology. Any questions?
Yes.
Oh boy.
Your STL is the file format that the software creates.
Mm-hmm.
So any software that's going to work with your printer must be able to create an STL file.
Right. About 90% of the existing CAD programs have the ability to save to STL as already. AutoCAD, Geomagic, your Libre lines, they all save as STL. When you get back, take a look at it, you probably already have the capability of doing that.
Draft site, Dassault, all Dassault products,
Right.
CATIA.
But you